I only know that. Find your derivative. I got it. I would know that code is like negative plus, and then bring the negative forward, and then sine.
All right, so I've heard some folks who said chain rule. Is there a chain rule here somewhere? No one sees a chain rule. You see a chain rule. Where do you see a chain rule?
I don't know, because that's where I get confused, because like sometimes when you're gonna use like x squared of e to the cosine of x.
Okay, I would never read this as x squared of e to the cosine of x. Never, ever, ever I would read it that way. How would you read it, Jonathan? Well, first of all, I hope we'd read this as x squared times e to the cosine of x. So this must be, what derivative rule? Has to be a product rule. You have no choice. This guy over here means you're going to have a product rule. Now, the part where there is a chain rule shows up over here where you're saying it's e to the power of cosine of x. So there's a little chain rule happening over there. You've got to know your product rule. You've got to know that there's a chain rule going on. You need to know that the derivative of cosine of x is, what's the derivative of cosine of x? Negative sine of x. You need to recognize here in this chain rule problem that the mama is e to the power of x. And so the derivative of e to the x is e to the x, right? We've got all that stuff going on. So a way that I like to organize my work on these tougher problems is over here. I'm going to use this d dx notation to mean that I'm taking the derivative. I'm not actually taking it right now, but it's a signal that says, hey, I'm going to go find the derivative. And in this first part, I'm going to focus on product rule. Everybody okay with product rule? So the product rule says take the derivative of the first part. Okay, that's what I'm saying here. I didn't actually even find the derivative, but my notation says, oh, I'm going to go find the derivative. So I'm going to take the derivative of the first part times the second, plus I'm going to leave the first part alone, times I'm going to multiply by the derivative of the second piece. Doing something like that automatically gives me some evidence. You know that it's a product rule, and I will gladly award anybody a point who organizes their work that way. Now, you can't stop here because you're not done with the calculus. You okay with that? Right? I've got calculus to do over here. What's the derivative of x squared? 2x. So that's what's happening over here. I've got calculus work to do over here. Derivative of e to the cosine of x. That's chain rule. The mama is e to the x. The baby is cosine of x. So the chain rule says, oh, take the derivative of the mama, leaving her baby alone, times the derivative of the baby. You've done a chain rule. Probably picking up a point. Finally, I still have to take the derivative of cosine of x, and the derivative of cosine of x is negative sine of x. There's like 3 or 4 derivative rules happening here right now, but using this d dx notation kind of lets you like stop and pause so that you're not doing it all at the same time. Questions on that? Awkward silence falls over the crowd. Was this a moment of silence to remember that it's Adriana's birthday? Okay, okay. All right, so let's push the envelope, shall we? All right, model problem number 1. Have a strategy conversation. What are you going to do? What derivative rules do you need? 6, 10, 13, 16, 19.
The big mama.
Let's see, who we're going to talk to? What rules are we doing for number 1? It's on that paper, the notes I gave you from yesterday. I mean, all the notes on
All right, let's get some hands on this. What derivative rules are we going to need here? I don't care about the answer right now. I'm curious what derivative rules are you going to need and why. Jose, what are you going to need?
I don't know if I'm right, but I think quotient.
Okay, you're thinking quotient. What part makes you think quotient rule?
The division.
Honestly, great. Okay, maybe a quotient rule happening over there. What else? What else? No idea.
Product rule.
Product rule. Where do you see product rule happening?
The x squared times f.
Right. I'm being sneaky here because I didn't even like give it to you. I just said okay, like I didn't give you the dot. I just said it's x squared next to f of 1 over x. Any other derivative rules? There's one more. Eunice sees it. There's one more. Remember, anytime you would say the word of, that is a chain rule. David, where is it?
So there's 1 over x of, yeah, right?
Wait, it's not 1 over x of.
F of.
It's f of. And as soon as you say that word of, that means chain rule. So for those of you that are feeling really good about your derivative skills, go find the derivative on your own. See what you can do. For those of you that are like with me, I'm just going to go through this step by step. Who are the folks that are with me? Okay, good. So if I'm reading this x squared times f of 1 over x, the first rule that I'm going to come across? Product rule. So the way I'm going to organize my thoughts here, g prime of x. Product rule says take the derivative of the first part. That's probably pretty easy, right? Derivative of x squared is 2x. But I'm going to leave the f of 1 over x alone because the product rule says derivative of the first times the second plus the next part.
Leave the first.
Leave the first alone.
And take the derivative of the second.
And then multiply by the derivative of f of 1 over x. This is where I might use my new notation and saying, oh, I know I'm going to have to take the derivative of f of 1 over x. I'm not actually finding it right now. I'm just sort of flagging it and saying, I'm going to come back and do that in a bit. Is that making sense? Mm-hmm. Right, the upside is, if we're looking at free response, I know I'm going to give you a point for knowing the product rule. You've demonstrated you understand the product rule. Now the question, what's the derivative of f of 1 over x? Careful, careful, careful. F of 1 over x. Chain rule says, David, what does the chain rule say? How would you find the derivative using the chain rule here if it's f of 1 over x?
So the derivative of the mom.
The derivative of the mama, what is that?
F prime.
F prime, but leave her baby alone. So it's the derivative of the mama, leave her baby alone, and then multiply by the derivative of the baby. Now somebody earlier said quotient rule. Jose, you said quotient rule?
Yeah.
And you're right. You can use the quotient rule to find the derivative, or you've got it memorized. You know what the derivative of 1 over x is. We've talked about this. It's not natural log. It's negative 1 over x squared. So I'm going to say it's f prime of 1 over x times negative 1 over x squared. And just pull the whole thing together. 2x times f of 1 over x squared plus x squared times that times negative 1 over x squared. If you want to simplify, feel free. X squared times negative 1 over x squared is going to be negative 1. You don't have to. I'm not even too worried about that. But I could say it's 2x times f of 1 over x minus f prime of 1 over x. For the folks that went solo, how many guys came up with this as your derivative? Let me just get a quick count on that. 0. Okay. For the folks that stayed with me, how are we doing?
I got that.
Yeah.
So you'll just leave it as f prime, like you don't have to write the negative 1 into
The negative 1 over x squared multiplied with this x squared over here to give me negative 1. Because it's x squared times f prime of 1 over x times negative 1 over x squared. All right, let's push the envelope a little bit more, shall we? I want to see what you guys can do with problem number 3. I'm just going to give you 1 minute, have a strategy conversation, get started on this. Not number 2, number 3.
We back, we back, we back.
Graph of the
Which one? Number 3?
Oh, no, number 2.
The graph is f of x.
Right.
Find h prime of 1.
Find the prime of h1. And prime of h4. So find prime of h first.
So but it gives you f of x. I don't know. Why does it give you f of x? Because this is
That's the original function, I think.
f of x.
We
Then why does it make this have?
So maybe I don't know why it's not f of x. Ignore f of x.
Mr. D,
Yeah.
why are you showing us f of x?
You'll find out.
See, you're gonna find out.
It's probably
The good news is, if you're confused by that, all the DC students were confused by that the first time I showed it to them as well.
It's a trick. It's trying.
What am I asking you to find the derivative of?
Of h.
h of x.
H.
Yes.
H.
Oh, so that's supposed to be like.
So just worry about h.
Just worry about H.
Okay.
But H is
Oh, but E has the f
Okay.
of x in it.
So then let's find a prime. I mean the derivative of h. Right?
Yeah. You know how to do that? Because I know how to.
All right, really important thing here. I've given you the graph of f and I've given you the equation, but I'm not actually asking you to find the derivative of f. You need to find the derivative of H.
Start off with
So if I'm going to find h prime of x, what's the derivative rule that I need?
product.
Here in some product, here in some chain. The answer is, go back and read it. Read it out loud. Like, you'll hear the word and you'll be like, oh, there it is.
E
to the
How am I going to read
power
this, Jose?
of
E to the f of x.
The best way would be to say e to the power
E to
of. So if you say it, if you actually hear it, then it's like, oh, clearly a chain rule. Because Nora, one of the derivative rules that you missed yesterday is that when I'm taking the derivative of e to the x, it's just e to the x. Mrs. Blakely, who teaches at East End, she is one of my favorite teachers out there.
He's just writing what was learned yesterday.
Teachers or students, the derivative of e to the stuff. This is like their version of the chain rule. The derivative of e to the power of stuff is e to the power of stuff times. No, that's not what the chain rule would tell you to do.
No.
It's e to the power of stuff times derivative of stuff. So times like stuff prime. It's the chain rule. You take the derivative of the mama, you leave her baby alone, times the derivative of the baby. If that works for you, go to East End. You'll love her. All right, so if I'm going to take the derivative of e to the f of x plus pi, then it's e to the power of f of x plus pi. The exponent doesn't change. Times. E to the stuff. Chain rule, right? This is e to the power of f of x plus pi times f prime of x. Not done. Right, pi is a constant. The derivative of a constant is going to be 0. Not a product rule. I don't see multiplication happening here anywhere.
Oh, I thought we were
Are we okay with h prime of x?
What about the plus pi?
What about the plus 1?
The plus pi. Because it's f of x plus pi.
F of x plus pi. The derivative of f of x is f prime, but the derivative of pi is 0. Okay, now, here's why I'm giving you f over there. You need to find h prime of 1.
Yeah.
If you're going to find h prime of 1, you're going to plug it in. You're going to say, oh, e to the f of 1 plus pi times f prime of 1.
My gosh.
The graph is there for a reason. Don't worry, you're good. What's f of 1?
Yeah.
F of 1 is 3. So I've got e to the 3 plus pi times f prime of 1. F prime of 1. You've got the graph of f. These skills cannot have possibly died on the vine yet. The derivative of f at x equals 1. I go over to x equals 1. What's the derivative there? 0. So your final answer is going to be e to the 3 plus pi times 0. Edgar, what are you going to write? 0. Hopefully you're going to write 0. For h prime of 4, same game. So it's e to the f of 4 plus pi times f prime of 4. F of 4, where's f of 4? It's really hard to read on the graph. Is that over here? Okay. So this looks like it's e to the negative 1 plus pi times f prime of 4, but you're at a cusp point. And if f has a cusp point at x equals 4, then the derivative does not exist. So your final answer does not exist. Okay. I don't want you to suddenly freak out and be like, oh my god, there's going to be tons of these tomorrow. No, not at all. But this is the level that I expect you guys can play at now. Because you're doing the homework, because you're getting the feedback, because we're doing all those things. So here's what I would encourage you guys to do tonight for homework. If you look on page 3, there are 8 problems in the top section. I want you to pick 6. There are 8 problems in the bottom section. I want you to pick 6. It doesn't matter which of the 6 you pick. Okay? For those of you that want to get a running start on your homework, you've got 7 minutes that you can do that right now. For folks that want to practice some like really, truly nasty problems and get better with your derivative skills, we're going to work through 2 or 3 problems from page 2. But you're either starting on the homework, which is 6 from the top and 6 from the bottom, or you're working with me on some of the more challenging problems. These are the 2 options. Who are the folks that are with me? Okay, then I'm going to ask the folks that are with me if you could maybe move up to the front, and folks that are getting it started on the homework, move to the back and the side.
He will be back in a moment.
We're going to go truly nasty. Okay, so Rambir's with me. All right, so my crew, I've got Eunice, I've got Kimberly.
I'm going over the paper.
Okay. You're with me? Okay, you're with me as well. Okay, I can feel the love and the energy. And everybody else, we're getting a good running start on the homework. 6 from the top, 6 from the bottom. All right, folks that are with me, let's look at this first problem. Kimberly, can you read that using your best math vocabulary ever?
G of x equals cosine of f of x
Cosine of f of x plus
f of cosine.
Okay, what derivative rules do we need?
Change.
No, you're right. There is a sum rule, right? The sum rule just says derivative of the first plus derivative of the second. That's not so bad. What I care about is, do you know chain rule? Okay, so I heard cosine of f of, those are my chain rules. And Jose, please label your derivative so I know what I'm looking at. Yeah.
Before we start identifying chain rule and stuff like that, would it help us if we found derivatives and stuff that already know, like cosine?
That's not a bad idea. You might even tomorrow on the quiz just be like, derivative of e to the x, d to the x, derivative of sine of x, cosine of x, derivative of cosine of x, negative sine of x, derivative of natural log is 1 over x. That is absolutely fine. But if you don't know those cold, you're dead in the water on a problem like this. And I don't know, those are some of the ones that you missed yesterday. So I'm taking the derivative of cosine of stuff. So the derivative of cosine of stuff is what?
Cosine stuff.
Careful.
No,
Derivative of cosine.
Negative sine.
Right, the derivative of cosine is negative sine. So it's going to be negative sine of right? You're doing a chain rule. We took the derivative of the mama, we left her baby alone. So negative sine of f of x times what was it?
Derivative of f of x.
Times f prime of x, right? I don't know what f is. I can't tell you exactly what f prime is, but I know that I need it. I know that I need to multiply by the derivative. And then Jose, because you said we need that sum rule, you're right. Now we're going to say, oh, let me go take the derivative of f of cosine of x. Ranbir, what's the derivative of f of cosine of x going to be?
F prime cosine of x
F prime of cosine of x
times negative sine
times negative sine
of x.
of x. There's always going to be an angle. There's always going to be an argument after that. Okay? All right, try the third one. See what you can do. I want to check in with the folks in the back. Because right, you don't know the function, you don't have any other values. Yeah, you get a question.
Oh, no,
You're good?
You just,
Right, sometimes I'm going to write the dot, other times you need to write the dot. No, because it's x squared. Yes, I'm combining like chain rule and product. All right, so friends up here. J of x is f of x times e to the f of x squared plus 1. Hopefully an obvious product rule. Okay, hopefully this is the obvious part. So J prime. Jose, how does the product rule work?
Derivative of the second time. What's the product rule?
Product rule.
So f of x.
I've got two things being multiplied together. The product rule says of the first.
What does it matter then?
It won't matter, but for the sake of like everybody staying in the conversation with you, let's find the derivative of the first part first. So the derivative of f is f prime. Hold on one second. Derivative of the first times the second. So e to the f of x squared plus 1. Derivative of the first times the second plus f of x. Now here's the place where like my old man brain is going to say, wait, I know I need to find the derivative. Just like let me like give myself a little bit of brain space here and say, oh, it's e to the f of x squared plus 1. So like I've completed product rule. I'm happy. The derivative of e to the stuff is e to the f of x squared plus 1 times derivative of the baby f prime of x squared plus 1 times the derivative of x squared plus 1 because that baby had a baby.
So the big.
Disgusting to think about. Okay. Adriana, happy birthday. I'm sorry we didn't get to publicly sing it, but maybe everybody will just like wish you happy birthday over the course of the day.